Okay, is it better? Okay, just give me one more second and I will be, let me try one more thing.
Hello, hello. All right. Okay, so let's try again. All right, so great. Let's start again. So far we have answered questions since past, and we would love to continue it from now. Okay. So the name node, I was trying to explain a very important idea. So when we say class, object, and this in memory, so in memory is better represented like we represent the uh, objects in the form of a tree structure, or you can generally say it a graph. Why? Because in the memory, jumping to a point and modifying that value is far more easier. Okay, but if you try to modify something in the disk, it's actually very slow. Okay, why? Because if you think about local storage, although we always talk about that it looks like a disk and it is a round and it has a spindle and so on. But if you think about it, the way data is written to the disk is sequential. So it's like a huge queue of bytes that are written to the disk. Okay. So this process of converting an in-memory object into something that gets written to the disk is called serialization. Why? Because we convert a complex object into a series of bytes, into a serialized data. Okay, now why I'm talking about this? Why I'm talking about this is when we write something to disk, it's extremely slow. Okay, modifying object is equivalent in the disk. Modifying and saving object is equivalent to rewriting the entire object. Therefore, instead of keeping on rewriting the entire metadata to the disk, because it will become too time consuming, and HDFS will be considered very slow. If on every modification of metadata, the entire metadata is persisted onto the disk. Therefore, instead of keeping the entire keeping on rewriting the entire metadata, a kind of logs are maintained. Two files in the disk are maintained. One image, other edit logs. The image contains the periodic snapshot of the metadata. Okay, while edit logs contain the modification instructions saying data got changed from this to this file got deleted, and this file got added, and so on. Those are called edit logs. Creating an edit logs is an append only process, meaning every time you create an edit log, a new append is done instead of modification. Therefore, creating edit logs is easier than taking the snapshot every time from the memory And therefore, in the disk, image and edit logs are maintained in two separate folders. Okay, is it clear? And earlier, when in Hadoop 1, we used to keep a continuous backup of image and edit logs. And in case name node fails, we install name node on any other machine and restore the metadata by combining image and edit logs. All right. All right. Now, earlier there was a concept called secondary name node. So secondary name node is actually not a very big different idea than this one. As opposed to its name, the secondary name node refers to the right. So yeah, secondary name node refers to a name node which is not really running, but it is just installed. In case a name node goes down, edit log and namespace is merged, and then the secondary name node is turned on because a copy of metadata was available in the network. So this is what, okay, this is what we call name node, secondary name node, and basically secondary name node is nothing but another name node installed. But every time name node fails, the metadata which has been backed up is merged and secondary name node is turned on. All right. A point from Prasun that could you take an example to explain image and edit logs? I'll try to say. All right. Imagine for time being that we have file one. Okay. Metadata. Okay. Let me take. This is our metadata in the memory. Okay, so as in when we created a file, metadata contained file one, okay, and it had some name. Okay, file one, and I'm just trying to make it look little structured. So metadata contains file one. It has got size, and it has got name. It has got blocks and block ID, something, and machine name. This is how generally the metadata would look structured. Metadata contains many files, okay, and let me just make it a little formatted. Good. So let's say there is file one, file two, and so on. File one has some size, it has got name, and so on, right? Let's say at any point, this is our in-memory data. You can see that it's a kind of structured information and it's a complex information. Okay, every file has got blocks. Every block has got the machine name, the data node location name, and so on. All right. Now, file one and file two. Now imagine, let's say image. Let's say we have kept a copy of this same in the disk as well. Okay, we have kept a copy of the same in the disk as well. Okay, so let's say this is what we have kept in the disk and this is what in the memory. Okay, now let's say we changed the name of this file Okay, we change the name of this file to something like this. Okay, now along with metadata, we will, instead of modifying the metadata, we will basically say here file renamed from something to this, to XXX. Okay, this way. And after some time, let's say file2 was deleted, this got deleted. So instead of updating, okay, this is image of metadata. Instead of updating the image, we will basically write in the edit logs deleted file2. Okay, let's say file2 got deleted. So from metadata, we will remove it immediately. Okay, but we will not remove it from the image. Okay, instead, we will just mark it in the edit logs. Make sense to you now, Prasun? Okay. Did I confuse you or did I make any sense, team? Okay. A question from Ravi. Will the image delete the file too forever? Yes, it will delete forever. Although as a note, Ravi, as a side note, that HDFS has been designed such that when you delete a file in HDFS, it moves into a folder called .trash. Okay, just like Windows, when you delete a file, it moves it into recycle bin. HDFS also has been designed in a way that when you delete a file, it temporarily moves it into .trash folder. A question from Sudhakar. What happens when log is corrupted? If log is corrupted, it is going to be very difficult to recover the data. Okay. So Ravi's question is, now Sunny's question is, will it be a bottleneck because size of image will become bigger and bigger? Yes. So this image will remain as such actually. Okay. It is the size of edit log that will keep on becoming bigger. This is the size of edit log that will keep on becoming bigger and bigger. Okay. So disk will, so generally the disk storage is not too much of a problem. Reason being that this data is fairly small. If it is so big, what would happen is the metadata, if it becomes so big, anyway, it would not fit into the memory of it would not fit into the memory of name node. Good, very great set of questions. A question from Manu. This image and edit log will be both in memory and disk? No, they will be only in disk. In memory, the metadata will be updated. It will be at the single place. There will be no edit log and image in the memory. Image and edit logs are only in the disk. Okay. A question from RS. Will there be any replica of edit log? Yes. So this is what we are talking about while creating the backup of metadata. The edit logs and image are replicated by us, not by HDFS. Okay, because this is HDFS itself. Okay. All right. Krishna's question is image created on daily basis? Answer is no. It is on demand. It is on demand, and generally what we do is we call the command every day so that it can back up every day. All right. The imaging is on demand. Whenever we want it, we can create the image. A question from Manu. So once the file is deleted, it will delete from image. Yes, it will delete from metadata immediately, while the image, uh, the image will not get any affected. It's only the edit logs which will reflect that you have deleted a file. Okay, when you merge both metadata and the edit logs, then that entry of a file from image will be removed. Okay, so pretty soon it will be on demand. All right. So Ravi's question is, edit log is simply a record for manual reference or something? No, it's not for manual reference. It is for automatic merging. It is, the edit logs are for programs, for the consumption of programs. Okay, it is used for data integrity. Rahila's question is, so it can happen that you can create a command for edit log and image log and call it for trigger when required. Yes, that's correct, Rahila. Thank you. All right, good, good. All right. Okay. Any other questions at this point? All right. Let me, let me move ahead. So we also talked about a situation. So, okay, let me start this part from the beginning. So both the first one, this one, both these two approaches are manual, okay? And therefore, since keeping the backup of edit log as well as maintaining a secondary name node, both of these approaches were manual. Okay, both of these were manual, and therefore Hadoop 2.0 came up with very good idea called high availability. Okay, in high availability you have two name nodes up and running, ready to serve. Okay, two or more, I'll say. So you have two or more name nodes which have exactly same status, and the interesting part is that whether client driver or data node, they all communicate to name node as well as all other standbys. Okay, which means the whole system tries to maintain multiple copies of name node. Okay, so every data node informs all name nodes. Similarly, every client driver informs all name nodes. Okay, but there's always one active name node while rest are standby. Standby do not do anything. They just are there for the emergency. And the moment one name node goes down, the other standby, any of the other standby takes its place. Okay, that's how the high availability is maintained. Now, your question would be, who takes care of switching between name node and standby? Okay, who takes care of this switching? It is the zookeeper. Okay, zookeeper is like a whiteboard on which name node and all the standbys keep on writing their name, that I am active name node, and the logic that is there in every name node is like this. Name node checks with zookeeper. If there is already somebody active, then it doesn't become active. If there is nobody active, then it will become active, and the same logic applies to all the name nodes. Okay, it's like calling the dibs, right? When you and your friends call a dibs on a chair, right? So whosoever calls the dibs first, they take the chair. In case your friend calls the dibs and they don't take the chair, they have gone somewhere, then you take the chair, right? So it is like that. Similarly, if one name node came up and saw that there's nobody who has called the dibs to for becoming active name node, then that name node will become the active name node. Okay. A question from Rahela: what if zookeeper fails? Very interesting question. And to answer to that question, I will basically take you through zookeeper. Okay, although zookeeper generally people skip, but what we realized was that zookeeper is the most important component in the Hadoop ecosystem. We cannot skip zookeeper because zookeeper is used by yarn, zookeeper is used by hdfs, zookeeper is used by hbase, zookeeper is used by hive, and it is also used by Kafka and Cassandra and others. Therefore, I would love to take all of you through zookeeper just after HDFS. Make sense to all of you? In an ideal setup, what is the max number of standby name node that we can expect? The max number of standby, two are sufficient actually. Okay, so one active and one standby is good enough. All right, because name node's design itself is fairly resilient. Okay, because it tries to avoid all heavy lifting, tries to respond very quickly by reading from the memory as much as possible. Therefore, name node's design tries itself to make it very low on load and fast in the response. A question from Rahela: does it even have standby for secondary name node? No, actually. Secondary name node was a design before Hadoop 2, okay? And that was basically a kind of very lame solution for backing up name node, okay? That one did provide backup, but did not provide failover, okay? All right. So zookeeper is also called quorum journal manager in this case, okay? Because quorum journal manager is that in the quorum we are trying to manage a quorum of the nodes, okay? That's how it works. So Sunny's question is there any concept of image and edit logs in Hadoop 2.0? Yes, it is. The idea of image and edit log is as such in the Hadoop 2.0 as well, because Hadoop 2.0 has name node and standby both, and both of these are maintaining edit log and image individually. Okay. A question from Sudhakar: in case data node gets corrupted, which process will clean up the space used by corrupted data node? Okay, so the basically, if a data node gets corrupted and has name node has understood that data node is no longer of use, okay, So name node will inform, name node is the name node that will take the corrective measure, as in finding where all those lost data node, those blocks are, and start replicating those amongst other servers so that this data node can be vacated. Okay, this data node can be kind of disregarded. All right, so it is the name node that takes care of that process. Make sense to you? Sudhakar, was able to answer your question? Okay, good. All right, all right. So these are very important questions, and it is nice to spend a little more time on HDFS and then move on to Zookeeper. Okay, but before that, we'll do the hands-on and we will take care of rest of the process. All right. So, all right. All right. Now, we have talked about how to keep the backup of name node. Then we also talked about how to keep a standby of name node. Now, what we have understood so far is that metadata is kept in the memory. That also means that in case metadata becomes too much, right? Metadata becomes too much, and the name node's memory will overflow. Okay, let me try to show you this part. If there are too many small files, let's say there are too many small files, there will be the metadata memory will go really high. Okay, so I'll give you an example. Let's take an example here. Okay, 1 million files of 1 KB each. Okay, all right. If each file takes, say, 100 bytes of metadata, then how much will this consume? 1 million files of 1 kilobyte each. If each file, I mean not 100 bytes, let's say 1 kilobytes. Okay, this is easier to deal with. Okay, if one file having only one block. Okay, let's think about this. Let's say there is a file which has only one block, and that one is taking only 1 kilobyte of metadata, right? 1 kilobyte in the metadata memory. Okay, 1 million files of 1 million files where each file is 1 kilobyte in size. How much memory will it use? Anybody? 1 million, 1 MB into 1 kilo. This is 1 GB, right? All right. All right. If this file was, say, 10 bytes in size, what will be the size of the metadata? Same, right? Because the data file size of the data file will not impact metadata unless number of blocks are changing. Okay, am I confusing you? Okay, so 1 million file of 10 bytes in size each would have this much metadata. 1 GB. Okay, now if you think about it, 1 million file 10 bytes each is equal to 10 MB file, right? And if you combine all these files into one file, right, it will be consuming only 1 kilobyte memory, right? Does it make sense to you? Therefore, if you have too many small files in the system in HDFS, it could consume a lot of memory, right? It could consume a lot of RAM, and therefore, number one, we generally combine data, combine files to form sequence files in HDFS. We will talk about sequence files later. Sequence file is nothing but a file containing many files, just like .rar, .jar, .tar. You know these files? Or .zip. Zip has compression, but tar and jar do not have compression. So the sequence file are created that way, and they're designed in a way that when the user wants to access a particular file, it could read it really fast, and there is no effort involved in encoding or decoding, compressing or decompressing. That's why this sequence file was invented, so that many small files could be combined into a single file and still be very efficient in reading and writing. So Tegu's question point is, so the file size does not affect the metadata size. Generally not, unless the file size is creating more number of blocks. If your file size is increasing from 128 to 129 MB, then the metadata will become double because there are 2 blocks instead of 1. Make sense to you? Is everybody clear about this philosophy? Wonderful. Wonderful. Please keep responding. If you want me to explain something again, I would love to explain it. Okay, just give me a sign that, yeah, I need to explain, because the chances are that I may have skipped some part. All right. Because for me, since I've been teaching for some time, I start feeling that people know this stuff. And because of that, um, I might skip. So do not worry if you did not understand, I would explain. Okay. So Manu's question is, so based on block, it's creating metadata? Yes. Basically, metadata contains file name, file size, each block's address, each block size, and each block's ID. This is metadata. Okay. Therefore, more the number of blocks, more will be the metadata. Okay. And or more number of files, more will be metadata, because more number of files means more number of blocks and more metadata. Krishna's question is, how system knows that to go as a sequential file, is there a configuration set? So basically, we create the sequence file. Okay, these sequence files that I have written here, these sequence file are nothing but like a zip file. Okay, we create these files and put it into HDFS. Okay, while accessing, we can read it in that way. A question from Ravi. Basically, data size magnitude increase does not increase the metadata size proportionately, but at very lower rate in comparison. Yes. Yes. Okay. All right. Good. So what we discussed is when you have too many files in HDFS, name nodes memory is going to be inefficient. So we talked about one solution that we will combine all these files into a one sequence file, or you can think of it as like a zip file, and therefore thereby decreasing many files into a single, collapsing many files into a single files, and then putting it in HDFS. Okay. Now, sometimes that's not enough. Sometimes that kind of approach is not enough. You still have too many files. And therefore, in those circumstances, in those extreme circumstances, you can choose something called a HDFS federation model. Okay? In HDFS federation model, the user, okay? So in HDFS federation model, what happens is we maintain multiple name nodes. These name nodes behave like independent HDFS itself. Okay? The only difference is that there is kind of mapping that we maintain, that if we are trying to modify this folder, we should go to this name node. If we are trying to modify this particular folder, we should go to the other name node. Okay? It is like mounting two file systems on your machine, like C colon and D colon. If you modify C colon, it might be on one network. If you modify D colon, it might be on another network. Similarly, in case of HDFS federation, we maintain something called mount tables, which contain the mapping between the folder and the name node. Some of the folders point to one name node, and some point to another. For example, if the user in this diagram is trying to access /mydata or any subdirectory or files in this folder, then the request for modifying or reading would go to name node 1. And similarly, if another user is trying to access mydata 2 and mydata 3, then the request will go to name node 2. Okay, and of course, since it's a usual name node, it might have its own standby. Similarly, the second name node might also be having its own standby. Okay, so you can think of it like two islands, two different HDFS file systems. Okay, the only difference is that they are utilizing the same set of data nodes, same pool of data nodes, right? Because as we discussed, that it is not because of too much data, it is because of too many files. Therefore, data nodes would still have enough space, right? And therefore can be utilized by both name node 1 and name node 2 to store their data. Just that both will identify their blocks very clearly by prefixing their own names. Okay, so not their own names, their IDs. Okay, because of the unique IDs of the block, they'll be able to maintain the mapping. Okay, so the pool of data nodes is something like a shared resource between the two name nodes. While for the user, end user, directly end user, it doesn't, it wouldn't be hassle, because the end user will talk to the client library, and client library will take a look into mount tables. Mount table is a file It's like if you are on Linux, there is a file called fstab which contain a mapping between which folder belongs to which drive and which folder belongs to which network folder and so on. The idea of mount table is very similar to that mapping, okay, whereby when we write to one folder, the change might go to one name node. When we write to another folder or any of its subfolders, then the change would go to another name node. Okay, Sunny's question is, with each and every name node be having its own data node? No, they'll be sharing the same pool of data nodes. Okay. A question from Sudhakar: are these name nodes in the same machine or different machine? They will have to be on different machines. Why? Because if you think about our reasoning behind having two name node is because the memory overflow was occurring, right? That was the main reason behind having multiple name nodes, right? Having federation was needed when one name node was not sufficient. The memory was overflowing. Therefore, it makes sense to keep the two name nodes on two different physical machines. Okay, very good. Very good questions. Okay, Pradeep's question is, one client checks multiple name nodes in different machines to read file until it gets, okay, a good point, Pradeep. No, because since it's folder level mapping, since it is folder level mapping, so a file is always, a single file is always on one name node. The information about a file is always one name node, not in another. Okay, make sense to you? Therefore, for the client, it doesn't switch between the two name nodes for reading a file. Was I able to explain? All right. Okay. Let me repeat Pradeep's question. One client checks multiple name nodes in different machines to read a file until it gets the file to read. Okay, let me explain again. So see, it's a folder level mapping. Anything to do with this folder, whether we are creating a file inside it or we're creating folders inside it, or we are adding more and more files into this folder. Okay, either we are creating files inside it, folders inside it, all of this will only involve one name node. Okay, not both. Similarly, if we are doing anything to data 2 and data 3, we are talking to this one. All right, great. Okay, Sunny's question is, a client wants to read a file called file.txt. How would the client know which name node should connect to? Client wouldn't know. Client will ask the client library. Client library contains this configuration file. This configuration file is what we do manually. And this configuration file has to be reflected on all the machines on which the client library or client driver is available. This client library or client driver is something that basically consults a file which contains the mapping and does the magic for you. Yes. A question from Ravi. One file is never split between multiple name nodes. That's right. That's right. Correct. Yes. Okay. Good, very good set of questions. Very good set of questions. Keep the questions coming. And yes, all right. Keep the questions coming. All right, because this whole theory is available everywhere on the internet. Okay, but your questions need to be answered. All right. So again, a quick recap of what is name node metadata. Metadata, the entire metadata, as I have told you, is maintained in the memory. And what does it contain? It contains the file name, how many replicas, the number of replicas, the block ID. Okay, this file is present in these block IDs, and so on. Okay, so all of this information is called metadata. Okay, there is on-demand paging of the file system metadata in the form of two files. One is called edit log, other is called image. Now, so if there are too many files, then there will be too much of metadata. If there are folders inside folders inside folders inside folders, if you create this kind of hierarchy and do not create a file, do you think you will still overflow name node? If you keep on creating empty folders, right? You remember those old school pranks where people used to keep on creating folders inside folders and inside folders and so on? Okay, so Pradeep, it's in both. So metadata is capped in the RAM as well as in the disk. In the disk, it is in the form of edit logs plus base image. Okay, all right. So a copy of the metadata is maintained in the memory, and all the changes are continuously saved in the disk as well in the form of edit logs. Okay, all right. Did I make sense, Pradeep? No. So edit log and image, right? I'll explain again. So metadata is kept in the memory as well as in the disk. Okay, in the memory, metadata is kept in the form of a complex object, so that whenever you are updating in memory, it can be updated very easily and quickly. And whenever there is a change in the metadata, we keep that change in the form of edit logs. And these edit logs are since the point we have created an image. So whenever we create an image, all the edit logs and older image get combined and we create a newer image. Okay. And then after that point, all the changes that start again will start creating the edit logs. Okay. Okay. All right. I think there is a confusion. So it's like this. How should I say? Let's say this is memory, okay, and this is I'll call it RAM, and this is the disk. Okay. Let's say in the beginning we had created the snapshot. Okay. And whenever we're modifying the object, it is also kind of this is edit log. We call it image, and this is edit log. Okay, I'm really bad at writing it. Yes, memory and the RAM is on the same computer. All right. So whenever making a modification in the memory, this is also called memory. Memory. Let me just write with the font. This is also called memory. Okay. So whenever we are making any modification to the RAM, we instead of modifying the image, the older image, we just keep on making the change in the edit logs. If we make any other modification here, let's say we delete it, delete something here, okay, then also that's a change we are writing. We're just kind of keeping note of all the changes, okay. While the image does not change unless we uh, force it manually, because if we try every time, if we try to change the image on every change in memory, what would happen? It'll take too much time. Okay, all right, does it make sense to you? Because appending to the disk is easier, while modifying a large object is always like rewriting the entire file, and therefore it will be very inefficient. On every byte change, even if it's like 1 bit change, the whole object it would be written, and that will take too much of time. Therefore, instead of modifying the image, it keeps on just appending to edit logs. Okay. All right, so that was the idea of image and edit logs. A suggestion from Sudhakar is writing the edit logs to the disk is a manual process in 2.0. This I'm not sure. I'll have to check. As per my understanding, the edit logs were there. Edit logs are a common way of creating. All right, I'll have to take a look. All right. Okay. I hope I was able to give a satisfactory answer for your questions. Okay, now we will try to understand this. Okay, we will try to do some hands-on now. Okay, we will try to do some hands-on now. Okay, so what we are going to do is we have 3 machines. Okay, one HDFS. Sorry, we have 3 file systems. Okay, one is your laptop or your own computer. Okay, other is HDFS. Yes, Ravi, as per my understanding, edit logs are created as in when we are modifying or updating a file. Okay, so now let's do some hands-on. All right, so right now we have 3 file systems. One is your laptop. Okay, second is the HDFS, and third is the web console. All of these 3 systems have their own file system, meaning they all have a place to keep files and upload and download files from. Okay, so if we are uploading the data from your laptop into HDFS, we will use Hue. Okay, we will use Hue. And if we are uploading data from HDFS to the web console or the vice versa, from web console to HDFS, we will log in into web console and run this command called Hadoop FS. If you want to directly upload from your laptop, if you want to upload from your laptop to web console, you can use SCP, SFTP, WinSCP, or there is a very nice tool called FileZilla. Okay, there's a very nice tool called FileZilla that can also help you upload, but that need to be installed on your laptop. Okay. So you can log in You can log into the command prompt using from your side to either web console, SSH, or PuTTY. If you have PuTTY on the Windows, you can log in. Otherwise, web console is sufficient. Okay. All right. So, is there anybody who needs a quick overview of Linux before we jump into? Yes. How many of you would need a quick refresher on Linux? Okay. So, all right. 1, 2, 3. Let me just count it. This is right. So, yes. How many of this? Okay. All right. Let me just grab yes now. Okay. So there are 10 people, 10 of us. 10 plus 1, including Vikas. So 11 people want to have the quick overview. I'll just keep the overview very brief. I hope that'll be good. All right. So yes, because that's something I would like to, emphasize a lot, because most of the tools that we are going to use, whether it's Spark or any kind of machine learning or any kind of tools that we will learn or any kind of ETL, everything is console based. Okay. Therefore, we need to get used to the console. All right. So for now, let's take a quick break. Okay. Let's take a quick break for 10 minutes. And back by 9:42 p.m. Hi everyone, should we start now? All right. Okay. So a question from Sudhakar. What is Hue and the role in HDFS? It's basically Hue is a web interface. It's basically this game. Give me a second. Okay. So Hue is a web application and it helps us interact with all these Hadoop's component via browser. Okay. All right. Okay, so let me just go through Linux console very quickly, super quickly, and we will try to do things as we talk. Okay, so I'm going to log in into No Big Data My Courses, and in case you are only looking for CloudX Lab, you can quickly go to CloudX Lab, and if you have logged in once via LMS, then you will be by default logged in into this. Okay, you'll be by default logged in into the uh, CloudX Lab. Okay, now coming back to the credentials, you can see that. Now we can simply, okay, so we have this, and let me open, first of all, let me open Hue. Okay, so what does Hue do? Hue is a component provided by Cloudera. It wasn't provided by Hortonworks. So Hue we have installed separately. It is developed by Cloudera as part of providing a web interface to interact with various components of Hadoop. It's a separate application. And Hadoop, the plain Hadoop from Apache Hadoop does not contain Hue. So we had to separately install it. Okay, so you can see that in Hue there are all kinds of query editors, like for Hive, for Pig, for Oozie, and for interacting with Zookeeper and HBase. Along with that, this one is for basically interacting with Oozie again. And you see the file browser on this side and job browser. So if you want to see the status of like how many jobs has been executed by me or by anyone, it'll show you all the jobs that are executed. You can see that somebody is right now running Hive job. Okay, and this is the HDFS. Now you can see that there is no name node and data node because that's a part of architecture. This is the nice neat interface HDFS provides us. Okay, just like any other folder and file system, HDFS also provides us that nicely. Okay, so when you click on this, let's say we click on this, we are reading a file. Okay, for you this folder might be empty. Okay, all okay, so right, so by default when you open file browser you will land in your home directory. Everybody is given one home directory in HDFS and one home directory in the console. Okay, those are the two home directories you are given. Prefer to keep your data in HDFS because in case here, if there is a loss, if one machine goes down, your data get replicated by the way of replication in HDFS. Okay, therefore prefer to keep the data in HDFS. Okay, the limitation in HDFS is that per user we have kept 4 GB in total consumption. So in case you have started filling up your disk, you can reduce the replication and your quota will be used. Okay. In case you really need more than 4 GB, 4 GB as in including all replication. If you need more than 4.2 GB, then just let us know. We will increase your quota. Okay. But I mean, we strongly, suggest that you do not keep too much of data because we already have kept data at a central location. All right. Now coming back to it, we have this is my home folder. You will have your own folder. This is inside user inside this. Okay. So you can see that these are my folders. If we want to upload a file, we can simply click on upload. Okay. So let's say I'm trying to upload, let's say this particular image. Okay. It's a public image, so I don't have a problem in uploading this image. And if you see, it has been uploaded here, you can see. Okay, so this image has been uploaded onto the HDFS. All right. Similarly, if we want to, let's say, upload today's notes, I can upload my notes from last time. Okay, that'll be better things to do. I'll try to upload the okay, let me just try to go to okay, where did I keep the I think it is in here, and we have which file should I upload? Is this today's? Yeah. So I'm uploading 21 January here. Okay. For me uploaded. Is everybody able to upload data into Hue? Yes. Only Tameka has done it. If you're stuck, let me know. I'll make you the presenter so that we can see, we all can see. Okay. Tegu and okay, Rahela is doing. Looks like everybody is busy in doing this. Good. Okay, so please try to log in and upload. If in case for some people, in case some people this file browser is not visible, okay, they can simply say this. No, it's up to you, Tameka. Okay. Just try to upload a plain text file. Okay, just try to upload a plain text file. All right. So you can see that we did not have to, talk to name node, data node, and so on in order to interact with HDFS. Okay. Is anybody stuck? How did you get to Hue from CloudX Lab? I basically clicked on Hue here. And in case you are in the course, you can simply go to the course page. Okay. Here. And in this section, it will appear. Okay. In this section, it will appear. It takes little time because these YouTube videos keep loading, and because of which the browser blocks the call. And yeah, that is one of the reasons why this CloudX Lab loads a little slow. It's only in the LMS. Okay. because there are too many videos inside this page. Okay. All right. Yeah. Thank you, Pradeep, to bring back the thread. Yeah. So we do not, as we saw that we did not even talk to name node or something. It was this Hue which is doing it on our behalf. The client library of Hue is doing it on our behalf. Okay. Under the hood, it's being done by the driver. Pradeep, did I make sense to you? Okay. So who else is anybody stuck in uploading data to the HDFS? Yes. April, George, Zianko, Kar, Krishna, Manu, Mohit, Mohsin, Nani, Narendra, Nitesh, Prasun, Ravi, Sahida, Shamit, Alvin, Hang, Pradeep, Rahela, Srini, RS, Tameka, Sudhakar, Sunesh, Vikas, Vivek. All right, wonderful. Looks like everybody is okay. Everybody's Hue is working and they have created. All right. Now, before we move on to interact with console, okay, first let's log in into console. All right. I am going to log in into console from here. Okay. Also note that when you are pasting the password there, it might not reflect, but it has entered the password. Okay. Unlike Windows, it doesn't show the asterisks. All right. Wonderful. Wonderful. And good. So you can see that the this is the console. This is actually a Unix machine. For some, it would be f.cloudxlab. For me, it is E. For some, it'll be G. And for some, it might be H. Okay. Tamika, I did not get your question. Are we going through HDFS, DFS, Hadoop? We're going through the HDFS. Okay. HDFS and DFS both are called same thing actually. Sometimes instead of saying Hadoop distributed file system, we call it distributed file system. Okay. Or did you mean to ask, are we using Hadoop 2? We are using Hadoop 2, of course, 2 dot something. Let me see what version is this. It's 2.7. Okay. All right. Okay, so everybody is able to log in into console. Yes. Shamit, are you facing a problem particular? Okay. You want me to see, take a look at your screen? Maybe there is a problem in copy pasting the password. Maybe click on the show password and try typing it as such. Okay, that could be another problem. Okay. So Samit, can you just send me a private message with your login password? I can open a web console here and we'll try it. Yes. Private message on the chat. That'll be okay. All right. So let me just help out Shamit a little bit and let me take a look at it. What exactly is wrong? Okay. Shamit, can you just send me a private message and it's okay. April, actually, it does not reflect that you are typing the password, unlike Windows. So you just paste your password and press enter. That should be good enough. It does not echo the asterisk or any other character. That's how the Linux work. Okay. Okay. Samit, before making you the presenter, so just send me the login and the password. I will try to log in from here. Yeah. Send me privately. Okay. Yeah, that's good. Let me try to do it. I'm able to log in. You can see that. I was able to log in with whatever login password have you given. Please note that the space before capital K is not part of password. Okay. Okay. All right. Sure, Srini. A question from Narendra. Would it be possible to display host name instead of IP address in Bash here? Um, Actually, no, because the translation, this one is the internal IP address. So we are not able to do that correctly. We are yet to figure out. Okay. That's why what we have given instead is these IP mappings tab in the CloudX Lab. It shows that which IP means which private IP address means which domain name. Okay. So thank you. Yeah, Naren, that one we are still trying to fix. Okay, let me check if it's working for. Okay, so Srini, okay, Srini, is it what console do you see in the URL? In the URL, e.cloudxlab F or G? Srini, do you see E, F, G in the console? Okay, E only. Let me open. All right. Anybody else be facing the problem? And okay, I'm able to log in correctly. Probably it's the problem with the copy pasting. Okay, just try to type it. I was able to do it. Maybe try to find out, is it 1 or I in your password? Okay, just copy paste it in different font and it should show you. Okay. All right, so I was able to do it and yeah. Good. So we all are able to log in now. Okay. Shamit, did it work for you? Great, great, wonderful. Srini, could you try again and then see? It should work because I was able to log in. Wonderful. So probably everybody is okay. Tegu's question is, what is the difference between E or F? What we have done is we have divided users between many hosts. Okay, we have divided users into many hosts so that if there are many users, they should not overcrowd one particular machine. That's why we have created E, F, G, and H machines for our users so that they should not block each other and do not overcrowd one. All right, that's part of our user creation. So we map each user to a host and accordingly display their the console link. Okay, now coming back to it. All right, so I wanted to give you a very fast overview of Linux. Probably this will be the most lame and uh, quick overview you will hear of Linux. So in Linux, the root directory is called slash. Okay, everything in the Linux is file. Okay, because just like in Hadoop, the way HDFS is very important. Similarly, to learn about Linux, the most important thing to understand is the file system. File system starts with a root directory called slash. And inside slash, you can create directory within directory, and you can keep on creating files inside directories. Okay, not files inside files, sorry, only files inside directories. The configuration file in Linux the configuration files are generally found in /etc. The information about the processes, like which processes are running right now, is found in this folder called /proc. Temporary data is stored in TMP. Home folder of people are stored in /home. I'll show you this part. Okay. And the way you move between the file folders is using the command called cd. And first of all, let's check what is our present working directory. My present working directory is /home/Sandeepgiri 9034, meaning in this folder called home, which is at the top level, it is at the top level, it contains this directory. If you want to go to the top level, we can say cd/. This is root. Okay. To see what's there in a folder structure, we say ls command. Ls shows us the list of files or directories. If you want to see the detailed listing, we can say ls-l. Okay. Now, a quick overview of what we are trying to do. There is a file system. We are interacting with the file system with these commands. These commands are programs, and these programs itself are the files. When we run this command called ls, a program is executed. Okay, a program is executed after the program has been read from the disk, loaded into the memory, and then executed. Okay, so ls is a command which shows us, when runs, reads the disk and displays the listing. Okay, you can see this is the detailed list of files. The first column means the permissioning. Second column means I think the size of the inode, meaning number of files actually inside a particular folder, and user and group, the owner of this file, and the group who is the owner of this file, and that these are the permissioning, and this is the permissioning. Okay, and this is the name of file, and this is the time at which it was created, the size of the file. Okay, D in the beginning shows that. Okay, let me just take it out, look a little nicer. Okay, so what you see here is this. Okay, so there are these list of files you see. Okay, now if you want to change the folder back to home directory, you can simply say cd enter. This is my home directory. All right. If you want to see what are files in a particular folder, you could always say ls etc. Okay. So right now we are standing on this machine. Okay. So whatever actions we do inside here, those actions are going to reflect as if they're emanating from this particular machine. Okay. So if you want to see if Google is working, we'll say ping. Okay. So basically this particular machine is pinging to Google and so on. Okay. So we are actually performing actions from New York right now because this machine is based out of New York in the Amazon cloud. Okay. So that's good. Now moving back to, yes. Okay, a question from Prasoon. The home directory in the Hue is /user/name, but in console, it's home and name in Hue. Very good point, Prasoon. Is anybody else, did anybody else, realize this part? Okay, so yes, that's why you see, I've mentioned there is your laptop, there is the web console, and there is this HDFS. In HDFS, you get this folder, right? In the Linux, on the web console, you get this. Okay, /home. So it's good that you noticed it because that basically shows that these are two different file systems. One is native file system of this machine, okay, of the web console machine. For me, it's e.cloudxlab. It has got its native file system, and there is HDFS, which is basically the file system here means basically metadata, right? And so on. Good. Okay. Now, so you can refer to a file either in the absolute way, saying /tmp or /etc/home, or we can say /home/sandeepgiri9034/something. Okay. Meaning, if the file name starts with /, it's called absolute. Okay. If it starts with any other character, then it's considered as relative. Okay, relative to current directory. Dot means the directory just above it, and then rest. Okay. Okay. From the command prompt or console, we can execute commands. Every command is made up of two parts. One, the name of the command, okay, which is the file name, and then the arguments. Okay, so command followed by parameter 1, parameter 2, and so on. All right, so that's it. Now we will talk a little bit more about HDFS. What is TO? Can we show the navigation from client to metadata machine to actual data file machine as a demo? That'll be difficult to demo, Ravi. That'll be difficult to demo because we don't have such a good debugging system as of now. Okay. All right. So we have already logged in using Web Console. If you don't like Web Console, you can either use SSH on Mac and Linux. If your laptop is on Mac or Linux, then you can use directly SSH. And if you are on Windows, you can use PuTTY if you don't like Web Console. Okay. All right. So let's log into this, not this. Okay. Here we are. Let's try to open let's say an editor. A quickest way to edit a file is here using Nano. Nano is an editor. Okay, we could say my new file.txt. This is my new file.txt is the file that contains that is newly being created. Okay, I'm just creating it. And when I say Control X, this editor, this text editor like Notepad is asking me to save it. And that's it. Okay, just to check what is there inside the file, you can see this. Okay. All right. Are you able to create your file? To save the file, just press Control X and then on prompt, press Enter or yes. All right, wonderful. Everyone, yeah, make yourself very comfortable with the console. Okay, and I will strongly recommend it to everyone. I've built this nice. I've tried my best to build a nice hands-on assessment on Linux, and I'm working hard on building these assessments. Okay, so I've built this 87-page, Linux fundamentals tutorial for our students, so that we can all do hands-on and learn in proper way. Okay, it's very good Linux basic guidelines as per my own understanding. Of course, I will tell that it's the best because I build it, and but I would love to hear your feedback on this. I'm hearing good things about it from other students. So I build it so that people, because whatever happens in the data science is still going to be Linux predominantly. Okay. Therefore, there is no way to deny it. The other important point to understand, all of you, is that now since Linux command will start working on Windows, it makes all the more sense to understand the way Linux work. Okay, from next few versions, Windows has adopted the same mechanism as Linux. Therefore, your knowledge of Linux is going to be very useful in the big data or data science or machine learning domain. Okay, or any kind of server side, the knowledge is going to be long term. That's why I built it for the students. And yeah, and this is very hands-on because it will ask you to do things in CloudX Lab, and only then you can move ahead. That way, it will make you do things on the lab. Okay. All right. To come, okay. If you are on Nano, yeah, just let me close my personal notes. Okay. All right. Okay, good. Now, yeah, I was explaining about my Linux this tutorial. Okay, I might be a little more obsessed about my tutorial, but please provide the feedback so that I can improve it further. Okay, now going back to answering your question. Okay, so these are the commands I was talking about. One is Nano. Nano is a text editor, a kind of a nice text editor, easy to learn. Okay, using Nano, you can open file, write something to it, and press Control X, and then on the prompt you could say Y and then enter. Okay, and then it will save the file, and you can check if it is done by printing the data of that file by using a command called cat. All right, so that is our first file. Done. Good. So keep keep this link with you. Okay. All right. Keep this link for Linux one with you. I'll also paste it here. So that, yes, can you turn off your video, please? Ravi, the video is on. Yes, Ravi, your video is on. Now it's good. Good, thank you. Hi, Ravi, are you able to hear me? I think he's not able to hear. That's fine. Okay, now we were able to create our file, right? Good? Good. Yes, go ahead, Narendra. Let me stop my share. Narendra wants to show the screen if just to ensure if he has done it correctly. Yes, please share the screen. Yes. Yes, that's right. That's right. So, yeah. So this, okay. Just Nano is an editor, and Nano, if you see the bottom line, it'll show you all kinds of keys that you can press. One of that is Control X to save the file. Okay. Are you stuck? All right. Good. Let's move ahead. Now, the first, another important part that we're going to do is copy this file from console to HDFS. Right now, when I say ls, we are talking to the local file system, right? We're not talking local as in this local to this e.cloudxlab.com. It's a machine, and we are talking to this local machine instead of talking to HDFS when we say ls. If you want to see, if you want to talk to Hadoop, from here, we will use a command called Hadoop space fs space minus ls. Okay? You see this? So this command actually lists files from the HDFS. Okay? So this Hadoop fs is basically a group of commands. So when you want to interact with Hadoop file system, you say Hadoop fs. And then it shows you all kinds of lists of the commands here. See these commands? These are the supported commands on HDFS. Meaning, if you want to append to an existing file, you use append to file. If you want to print what's there in a particular file, then you say cat. If you want to compute the checksum is like a signature of a file. And if you want to change the permissioning, you use chgroup, chmod, and chown. Okay, the permissioning in Hadoop is very similar to the permissioning in Unix. Okay, now if you want to upload a file from local to HDFS, then we use a command called copy from local, right? Now I'll show you. So when I say cat, what is the file name I created? I created my new file, right? This file is not there in Hue. Okay, this file is not there in Hue. Where is Hue? Here. You can see in file. Yes, Tameka, that's right. It would have uploaded your file into the HDFS. Okay, copy from local is also basically put. Okay, so you can see that there is no such file. All right, there. But when I upload it from here, I say Hadoop fs copy from local, or I say put. It's the same thing. Okay, it's the same thing. Good. And you can see that it'll appear here. All right, I'll have to order by date because I have just too many files. Okay, so you can see this. It is uploaded here. Okay, is it clear? So from console to HDFS, we use Hadoop fs command. Okay, directly from your laptop to this HDFS, you use only Hue. Okay, from your laptop to the console, you use SCP or FileZilla. Okay, you can download FileZilla if you're on Windows. If you're on Mac or Linux, you can simply use SCP. Yes, you can actually use upload zip file like this. Naren? Okay, all right. All right. For unzipping, you will have to download it, unzip it, and then upload individual files. Either that, basically, I mean, to unzip directly inside HDFS is not possible. Okay. All right. Good. A question from George. I'm not able to use Nano to create file. Okay. Let me just stop sharing and take a look at your problem. Okay. Could you show me the screen? Okay. So yeah, you are using VI. Okay. VI is also a good way to add it if you are good at VI. Now the problem is that you have gone to the top level. If you say PWD, say PWD, you are at the top level directory, right? And at the slash, people are not allowed to modify because that's the top level. You're only allowed to modify your the file in your home directories. So press this CD, just press CD. That should take you to the home directory. CD, enter. That's it. Okay. Now you can create the file in howsoever way you want. So when you were in home and you said ls, that list of files is nothing but everybody's home directory. Yes. You can put some file name. Yeah. All right. You can press enter and that's it. Yes. Did save ls? Say ls. Wonderful. Now you have this file. You can say cat my file. Also, if you are wondering what happened to the extension, it doesn't matter in case of Linux. It doesn't matter what is the extension of the file. Okay? It doesn't impact the file in any way. Okay, let me, there is a button